So welcome everyone to our next Innov8 series. We've got a great guest with us here today. We'll do our go through our spill. Let's go to the next slide here, Jim. And we'll just quickly show on the next slide our Zoom administrative stuff, just so everyone knows where everything is on the screen. Hey, Jim, the slides didn't go forward for me. Oh, there they did. Just took a moment. Believe by now everyone's pretty familiar with Zoom, but we always like to just put this up on the screen just to do a quick overview. Let's go to the next slide. And I'm Timothy Summers, Executive Director of Cloud and Advanced Network Engineering Services and at ASU, and specifically in our University Technology office. And I am your host, along with Aaron, and we're excited today, really, because we're going to be listening to Jim Nasr, and Jim is CEO at Acor, and I had a poll pop up in front of me here. So Jim's the CEO over at Acor, and which is a technology firm focused on building usable, open, blockchain-enabled software, specifically for healthcare. And also the acting CTO at Asg Health Systems, a digital health platform provider, rather. Prior to his current roles, Jim was chief software architect at the U.S. Centers for Disease Control and Prevention, CDC, which we've all been interacting or at least learning things or hearing about them in the news in some way, shape, or form these days. Where he led the modernization of the agency's scientific applications, culminating in the development of Open CDC. Jim has more than 20 years of experience in the technology industry, with over a decade as a founder, profitably growing the technology firm Media LLC from inception to over 100 employees and a 5-time Inc. 5000 awardee. Jim has co-authored several technology books, guest lectured for a number of universities. And something I'm really excited about is that Jim teaches a semester-long course on token economics for the University of Georgia. He's spoken globally at numerous industry events and just is a huge thought leader around software development practices and implementation of blockchain. He's also a work group lead for IEEE Decentralized Clinical Trial Standards Body, architecture lead for the Fuse Blockchain Working Group, and a number of other technical groups in this space. Without further ado, really, Jim, I just want to kick it over to you. I know quickly we have a slide here just reminding everyone to sign up on our meetup, join us here, encourage your friends, encourage others, anyone that's interested in some of this stuff like we are, please have them come and join us. So without further ado, Jim, let's kick it over to you, man. Thanks for joining us today.
All right, thank you, Timothy. I appreciate the very kind introduction. There's a poll appearing here on the slides. Let me see if I can remove it. Can you guys see my screen okay? Can you see the presentation?
Yep, looks great.
All right, super. Thank you, Aaron. Thank you, Timothy. Yeah, I'm really excited to participate in this great Innov8 seminar. As you intimated, Timothy, I've been working with ASU for a number of months already on a project, and I really have a tremendous amount of just enthusiasm for ASU and what it's doing as a large public institute in innovation. I see it really at very much the ground level, close up, working with a lot of your colleagues. And yeah, it's really great to see. Also, I know that ASU has a real kind of point of view and efforts around blockchain. So that's really good to see too. It's really, I think it's important for our public institutes and students to understand blockchain, understand some of these emerging technologies, know what's real, what's not so real, but also really experiment and tap into, people like myself and other folks in the industry to really build interesting products and innovate on it. Anywho, so really the gist of my conversation today is about, is blockchain real? Is it still kind of very nascent and nothing more than a proof of concept? really the idea that, can we use it as a practical layer of application trust? And I think I will let you make that judgment after I'm done, but certainly I'm going to give you some examples to back up my ideas. All right, moving on. So basically in 3 acts, I don't quite know what the audience composition is for this webinar, so I think it's important to just do some basic baselining and not to get into all of the bits and bytes and spend an entire session on it, but I think some of the key principles, particularly key principles that shape like my thinking, my company's thinking, what we're really all about. I think it's important to understand because that's the underpinning of the rest of the conversation. In today's reality, I want to talk about what substance relevant about blockchain. What is a signal, not so much a noise. I think there's a lot of noise, and I'm sure most of you guys on the call are probably familiar with much of it, whether it's cryptocurrencies of different flavors or ICOs or exchanges or DeFi or you name it. There's a lot in there. Those are to me manifestations of an underlying kind of set of offerings, infrastructure, if you like, in blockchain. They don't define blockchain, right? So I'm trying to stick really more about the substance and really ultimately what's practical. And then to kind of segue into really some specific use cases that we are working on, because I think that's probably the most interesting, including some of the work we're doing directly with ASU. So that being said, here's our Act 1. Just a little bit about myself, ACOR, but also perhaps more importantly, some of the key principles that really shape what I do, what we do, and then you'll see that kind of really play itself out over the next few slides as we talk. But really, we are a software development firm where we build really what I consider as modern usable technologies, primarily focused on healthcare. We blockchain-enabled technologies where it makes sense. It doesn't make sense in every case, right? Blockchain isn't a hammer and everything is not a nail. We have to be a lot more surgical, and you have to be a lot more intentional about where you use it, how you use it, and frankly, how do you justify it? So not a panacea, and there's still a number of things that you have to really consider. End of the day, for every project, there is an expected return on investment. Somebody's paying for these things, and it's important to kind of really understand that. And nothing really is a free lunch. As Timothy mentioned, I have a fairly longish background in software development, and certainly a lot of the work that we're doing now is really a continuation of work I've done over the last few years, around building open technologies, particularly OpenCDC and other large-scale healthcare platforms, including the Safe Mayo platform that we are also working on and ASU uses. And then my partner, Ben, is also a very, very well versed and extremely talented hands-on architect. So he and I worked together for about 10 years on various projects, and get along well and really kind of try and, as much as we can, kind of do what we say. So that being said, so I'm sure most folks on the call have heard of Moore's Law, right? It's a very kind of a common concept, how technology gets cheaper and faster roughly every 18 months. And that essentially leads to what is the red line in my diagram, which is increased productivity over a course of time, right? The blue line is the literal reverse spelling of Moore. It's called Eroom's law. It isn't my law. It actually does exist, and a lot brighter people than myself have articulated it. But it's really kind of, if you like, the underpinning reason of why we're interested in what we do, especially in healthcare. Because if you look at this over a course of 6 or 7 decades, you see an exact reverse pattern in productivity in drug development, which is an incredibly expensive time consuming, as we have also seen, certainly with the COVID vaccine situation, incredibly important and life-saving endeavor, right? But the results are woeful, and unfortunately, this is not an isolated situation. This is really indicative of how incredibly inefficient healthcare is, at least in the US, how incredibly wasteful it is, how in spite of the fact that pretty much every other industry is banking on Moore's law to get faster and cheaper and better, the drug development industry has declined hugely, right? So where we see ACOR going, where we see our value really is this in the middle here with this opportunity of, here's my mouse, of leveraging some of the emerging technologies that really are in play and are maybe kind of mainstay really these days. Certainly mobile technology is, IoT wearables, distributed ledger technologies, machine learning, etc. To really use some of these to help bridge or at least close this giant gap, right? Because it's a really big gap. This has, again, I'm a data person, and these are like scientific, factual data points, not made up by me. But the proposition here is that we're able to, essentially use some of these emerging technologies to improve things because they need to be improved. I think we all see that, we all know it, and I think, unfortunately, with COVID, we are all experiencing the downside of this. Moving on. So, again, not to get into too much of software development and, kind of basic things that we do in terms of building software. But it is important to kind of understand the mindset that at least I have, I think many people have, in terms of what it takes to build modern software and how you go about doing it in a way that allows you to build, build fast, fail early, but build well, build technologies that can be scaled, that can be reliable, that can be secure, and so on. So, I came up with this concept of software as a theme park. There's an article that was published, I think, in 2017 by myself through CDC. There's a blog that talks about this, but it's really this concept that, imagine if you go to, let's say Six Flags, I know pretty much all of the theme parks are closed these days, but we have to use our imagination. So you go in there, you go through the turnstiles, you get your ticket, right? And then thereafter, your experience can be different depending on your needs, your constraints, your desires. So if you have a family with 2 small children, maybe you're not going to go to, the roller coaster. Maybe you're going to go to the kiddie land, maybe to the water park, maybe you're going to go to a restaurant. But if you have a group of teenagers, maybe they're going to go to the Goliath first, right? And then the racetrack, and then maybe they do the island of adventure, whatever. However, none of those experiences are outside the theme park. You're still within that theme park. You still have the same common walking trails and monorail, and restaurants and security guards and color, color designations and things like this. So that's really the idea that we have in terms of software, which is, look, you're not going to have it would be foolish to say one vendor or even 2 or 3 vendors are going to provide you everything you need in this day and age. It's just innovation moves too fast. There are too many constraints, too many demands, and too many needs that we like to be able to kind of get into production and use much earlier than just waiting. So, if you wanted to, for instance, in your theme park, have a blockchain playground, that's a different experience than if you have a machine learning playground. However, the experience should not be different in the overall picture, as in your users should have one experience, one set of IDs, one way that in our kind of lingo abstracts all of these playgrounds. And that's really again, not to get into this in very detail, in a great amount of detail, but this is really the concept of software as the theme park. As you can see on the right-hand side, there are 3 layers to this concept. The top layer is really what I think of as a functional layer, or the theme park layer, what you can see. The middle layer is a blueprint layer, which is really the software, the underlying software, much of which is open source in the way we build things, and small modular software, and I'm very much exposed to application programming interfaces, APIs. And then the bottom layer is really the glue that binds these, is the DevOps layer that really helps you automate this, roll it out in a way that's efficient, reliable, can be secure, because otherwise it would be just too much complexity, and you would not be able to actually implement it. But anyway, this is the basic underpinning of how I think and really how we build software. And I think it's important as we go on in this conversation just to have a picture of this way of building software. And then to kind of give you a lower level picture, this is really how you deconstruct that actual software, this interoperable software, which is that really, and again, not to get into a software development lecture, but really is to take functions and break them down into their most atomic or smallest sizes, and then build an application essentially by meshing up different modules, or different, in this case, microservices. So this, what you see here on the right hand side, is a real application that we actually built at the CDC. These are kind of essentially specific components that we built for this application, and all of these are common application components that were available in general for the rest of the theme park. And then the meshing of them together essentially created this application. So again, this is a fairly well-known concept, and it's been in practice for a number of years. And I think if you're already familiar with this, hopefully you would agree. If you have any questions about this later on, I'm happy to take on some questions and just maybe explain a little bit more. I don't want to derail the conversation too much, but I think it's important to understand some of the key concepts. So moving on, that was really kind of a quick block and tackle on just the general concepts, but now a little bit more specific to blockchain. So again, most of you guys here on the call are possibly, hopefully, already somewhat familiar with blockchain, and I would assume you are, because you're on this call. So really, blockchain is a mechanism to help you provide trust. It does other things too. It helps decentralize processing and a number of other kind of elements. But I think the key thing is this idea of providing trust. But it doesn't, in of itself, it's not a structure really for managing your data. It's really a structure to manage or provide a layer of trust for your data. So the thinking that I have is, before we talk about blockchain, we need to really understand data. So data before blockchain. So basically, like, where is my data? That's an important concept. You need to understand where it is. In the world of healthcare, where I'm largely operating and we largely work, the data is siloed. So it's not one giant system you go to. It's not just like I go to Google or Amazon and everything is there. It's in many, many different sources, some of which play nice and have APIs, and you can get to them fairly easily, particularly these days with what's called the FHIR standard, the Fast Healthcare Interoperability Resources for healthcare. But there are many other systems that are really perhaps a spreadsheet or an Access database or esoteric old mumps systems and things like this, not very easy to get to. So really have to understand where it is. Beyond that, is this idea of, can you get to the data? Okay, yes. So now you know where it is, but do you have the credentials to get to it? Do you have the right transformation engines or translation engines to be able to get to it, etc.? Where's my data? And this is really kind of like taking this concept of, particularly in the world of healthcare, where data is, to where's my personal data. Some of you guys may be aware of what's called the Cures Act, which it actually becomes law at the beginning of next year, which allows you as an individual to be able to get to your data from your electronic health record provider, and be able to access that from your app of choice or your essentially agent of choice. But just because you have that, it doesn't necessarily mean that you can get to it. There's still some more hurdles to kind of go over and be able to provide the right kind of consent and know where your data is specifically, and so on. This is a this next one is a huge concept, and it's one that is really the underpinning of a lot of the work that I do or we do, which is, can I trust the data? So, and I think we have to differentiate between the data itself and the flow of data, because they're not necessarily the same thing. So I'll give you an example. If I go to my doctor and I'm having my physical, and the physician there records my height as 6'10", as opposed to what I really am, 4'2". That data is technically accurate because they put it in. It wasn't tampered. It's incorrect data. But then let's say that data moves along, and then the next system gets it, and instead of 6'10", which is what's recorded, the data is somehow corrupted, or somebody accidentally then changes that source data and makes it 5'10". So can I trust the data? Well, the data seems like it's correct, but if I look at the chain or the flow of data, I can see how the data has changed and how it's gone from the original input by the physician to maybe some transformation by a system, and now the data's changed. So that's really kind of the thinking is, essentially, can you trust the data itself, and can you trust the data's, essentially the chain of custody of the data, and has that been manipulated, has that been tampered with, and so on. And I have some more examples of that that are a little bit more discrete, so we'll talk about that. Then after this, what can I do with the data, right? So yes, okay, now you have access to it. Maybe you can trust it, but what can you do to it? Can you provide it to a medical research outfit and have an opportunity to monetize that data for clinical research? Do you have a way to get that data into a data market? Do you have a way to put it onto your mobile device, etc.? There are many questions around this. And then, last but not least in this scenario is really who's accessing data. And this is very, very important also when you talk about medical data, because whether you've given essentially a one-time consent to a physician, or whether it's discrete transactional consents, you want to know who is accessing it, and are they allowed to do so, or is that consent that was provided 5 years ago still valid, or are they within the scope of what they're supposed to do? So if I give consent from my orthopedic doctor to look at my health records, that should not mean that they have access to my mental records, or to other kinds of records that have nothing to do with their orthopedic practice. So that's really kind of what we're talking about. And again, the big thing here is that, and this is what we're going to try and essentially prove, is that with blockchain, you're able to provide a layer of trust, and at least some way to see whether or not this data has been tampered, manipulated, changed, and provide that layer to the data without necessarily impacting the data itself. So moving on, I think that was a little bit academic, but hopefully some of these other ones bring it back into a little bit more of a blockchain specific concept. So I mentioned really blockchain as kind of a layer of trust. And to me, we have to differentiate between trust as in, well, yeah, I mean, we could say that you have an entity such as a bank or an exchange or whatever, or a public institute like ASU, and they're trustworthy. You trust them, or Amazon, right? Amazon, that they have billions of dollars, so they must be trustworthy. There's a difference between that, though, than what I think of as computational trust, because when we're talking about blockchain, particularly the public manifestation of blockchain, there's an opportunity to essentially trust the cryptography, trust the software, which has been vetted, proven, and is constantly being challenged. Bitcoin is a very good example. Like, the Bitcoin network has never been hacked, right? You don't have to trust me because I'm a good guy, or ASU because it's a great institute, or Amazon because it's a giant company. You can trust open source technology, you can trust cryptography that's proven over many decades. And to me, that's really where I like to go. And you'll see this very commonly when people talk about private blockchains, which we'll talk about in a little bit, where essentially you have a number of known nodes. They're invited, they participate in some kind of a consortia, they work together. There's trust there, but do I think that's really computational trust? I'm not really so sure. I think in many of those cases, you essentially have a leader, and the governance can be essentially managed by a very small group of nodes. To me, I see computational trust as being a manifestation of using a public ledger primarily, with some exceptions. Moving on. So again, blockchain, I have a few ways of visualizing blockchain, but I really think of it as plumbing, right? So an example here is if you go to your shower and you turn on your nozzle and the water's coming through, like that's an application. The thing that's actually making the water flow is in the basement compartment. It's all those pipes and your water heater and things like this. Really, it's infrastructure, and that's, to me, it's a simple little visual, but I think of it like that. So if I'm out there, I turn on the faucet, the water's coming, the thing that's really making the water move is underneath the tiles, right? And that's the pipes, and then that's everything else that you see below. Just a little visual. But also, I think it's important to kind of understand that blockchain is not some magical thing. It's a number of kind of infrastructural things that provide you trust, primarily, but certainly some other features as well. So I did mention we start with computational trust. Anything else? Well, it turns out there's a lot of other things that you have to understand. And again, we could spend certainly an entire session, if not many more, on every one of these topics. And I'm not going to bore you by doing that. I think that will be a little extra duty on your behalf. But just to mention some things I already kind of mentioned briefly. There's this concept of public versus private. Just as a quick example, Bitcoin is a public blockchain. Anybody can join it. It's permissionless. You can go to a number of network explorers and see exactly in real time what's going on, transaction blocks and so on and so forth, the mining, etc. There are many private blockchain kind of implementations. It's largely publicized through IBM and Fabric. Not by any means the only one, but it's the one that seems to be on TV a lot. It's usually a consortia. It's limited. It's a closed ecosystem. You don't really have transparency, not certainly at a public level. There are network nodes, which is really the machines that actually run the software, right? Because blockchain really is the network, but software that's running on these machines. Tokens, I'm going to talk about in a little more detail shortly. It's a very important concept. It's one that really infuses game theory into your applications, and it's also a critical component of blockchain security, particularly public blockchain security. And really, many people believe, and as do I, that the more freely distributed and diversely distributed tokens, the more secure your public network is, your public blockchain implementation. There are many different protocols, and again, we could spend a lot of time on that. We talk about Bitcoin, and there's Ethereum, and there's many other ones that we can talk about, but I'm not going to do that right now. There's this concept of consensus algorithm, which is a very, very important concept. It's ultimately the thing that allows a number of decentralized independent nodes to work together and to basically agree, computationally speaking, agree that a transaction has happened, and maybe timestamp it, maybe have a fair sequence of the ordering and things like this. So the most popular one that most people have heard of is called proof of work. That's what Bitcoin uses. It's expensive by design. It's designed to be slow. It's designed to consume a lot of energy. But the reason for that is that it essentially provides you a lot of added security, and again, nothing is 100%, but it in many ways provides you a mechanism to tamper or to stop tampering and stop bad behavior and bad actors and hacking on the system, because it takes a little bit of time before the algorithm is completed, before all of the nodes have been updated with, with the different entries in the ledger and things like this. Again, we could spend a lot of time on this. Proof of work is, if you like, the most well-known and classical consensus algorithm, but there are many other ones, and particularly many faster ones and less expensive, more economically viable ones. So the ones that we use in our technologies is called Hedera Hashgraph, and it's really a kind of a proxy voting consensus algorithm. Again, not to get into all of the details, but just to say that there's a number of different kinds of ways to get to electronic consensus. Scaling is something that many of you guys may have heard about, where people say, well, blockchain doesn't scale. And I think I would encourage you to dig into that a little bit more, because it's not such a kind of a binary statement, and you really have to understand the context. And many times what you need to do is really build your technologies in a way that, going back to the concept of the theme park, that allows you to scale the technology at large, not necessarily just the blockchain. Now, I'll talk about that in a little bit as well. Smart contracts, I think that many people have talked about this. It's really a way to script some rules that you can run alongside your transactions on a blockchain. Again, I'm not a particular fan of this. I'll talk about this in a little bit later. It has many limitations. It has a lot of overhead. It's quite costly. Many areas, it really kind of like binds you, and you're unable to really be able to do what you want to do at an application level, etc. But again, we could speak at length about that. Key management is a very, very big concept. It's really ultimately the mechanism for managing the cryptography and the cryptographic signatures and the keys that you need for being able to encrypt and decrypt information. It's a difficult concept, though, because, or not difficult concept, it's difficult implementation, because it is quite technical, and for an individual user or consumer to be able to really get comfortable with it is not a trivial process. It takes some know-how, and it really has not yet been consumerized. I think those of us who are comfortable using our mobile phones are not necessarily going to be as comfortable thinking that key management for this kind of context is going to be as easy to do. And there's also issues around how do you recover keys that you lose? What happens I'm sure many of you guys have heard stories of people losing their private keys and then losing tons of Bitcoin and things like this, but unfortunately it's real. On-chain versus off-chain is a very important concept. Again, kind of goes back to my theme park picture, where blockchain was just one of the playgrounds in the theme park. And I think you really need to kind of understand that to build good software, because many things you want to do with blockchain will be off-chain, either because they're legacy systems or because you're dealing with data that does not belong on a blockchain for a number of reasons, or because it's just a lot more efficient and makes a lot more sense to have it off-chain. So, and many other concepts such as partial ownership of assets and things like this. Moving on, let me make sure I'm doing okay with time. Okay, I gotta speed it up a little bit. So I think of really kind of, like I mentioned, I think of public blockchain as really being a very important concept, in what we do, and really the big, if you like, the big enabling technology for getting computational trust, right? So, not that you couldn't do it in other ways, but certainly that's the way we go about it. But really, what is kind of a DNA of a public DLT? I think of it as really three things. So there's technology that we've spoken about, the distributed ledger and distributed database, if you like, but that's really not the most interesting part. There's the value creation, which is really this idea of tokens, where I think of it as essentially value creation attribution. That means that, for instance, the miners who solve that mathematical puzzle on the Bitcoin network, and they get the 12.5 Bitcoins as a result, they are creating value and then they're getting attributed to it. That's a very important concept. And then finally, this culture of decentralization, that, you know, we're not going to rely, or we don't want to rely on Google as being the only source of truth, or as the one central source of data for everything that goes on in our lives. Because what happens if they're hacked, or what happens if, you know, if they have some bad actors within that, you know, within their data centers and things like this. So all to say, it's much more than just the technology. So some of the key characteristics, again, I think I've mentioned most of this already, so I'm not going to belabor it, but really, I think all of these are important concepts in a public DLT, and you know, certainly tokens is one that I've gravitated to quite a bit, because to me, it's the tokens and token economics that allow you to affect human behavior. Because you could have all the greatest technology, but that doesn't mean you're going to be able to change humans' behavior. And if you can't do that, you won't necessarily get the benefits from the investment. So moving on, we mentioned token economics many times, and again, it's a very big topic. But essentially, in a very simple picture, you have this idea that there's a token. A token really is just a digital unit, right? You know, it's a unit of value creation. You could call it whatever. You could call it Bitcoin or Ether or whatever, Jim's coin, etc. And then on the right-hand side, there's a market, you know, and you want the market to be as much as possible a free market, where there's true supply and demand, as you would see with, you know, an open market or free market like the stock exchange. And then really this idea that when you kind of look at the network effect, the growth of this is when you bring the token and the market together and essentially figure out how you can incentivize the market to use the network by taking advantage of the tokens. Here's another little picture that you know, describes this a little bit better, and again, kind of alludes to this idea of the game theory, right? Which is, one, how do you enter? How do you enter this network or this concept? Entering is one thing, but many people enter, you know, and they leave straight away because it's just not that interesting. So then how do you stay and play? You know, which means now you have an incentive to continue. Now, there's something interesting there. And the tokens really largely play into this. And then finally, how do you captivate? And then if you can get to captivating, now you're really growing the network. Now you're increasing the value of the tokens. And that's exactly what we've seen with the Bitcoin network, right? From late 2008, early 2009 to now, 11 years on, you've seen the growth, you've seen the value, this hodling of Bitcoin. But it's really because there's a perceived value in not just the network itself, but also the tokens. So moving on, this idea of private, public-private, I think we've spoken about a little bit. And again, we could speak about this quite a bit. But what I'd like to introduce is this concept of a hybrid blockchain, which I think is actually quite exciting, quite interesting. And there's some practical implementations already. Again, early days, but it's really this concept that you could have your private DLT where you have your consortia of let's say 5 hospitals working together. You know, they're part of one, you know, network, if you like, and they share patient data amongst each other using VPNs and a public, rather a private blockchain implementation. But then certain messages, not every message, but certain messages, such as if somebody within those hospitals took a COVID test and was symptomatic, that message is broadcast to a public DLT. Again, not to announce who the person is, right? Obviously, that's a violation of HIPAA, but just to provide a trustworthy record on a public ledger that says a male between the age, I don't know, 20 to 50, you know, in the state of Georgia, has been diagnosed as symptomatic, as example. That has significant value beyond the private blockchain, right? You know, for all kinds of people, for public health, for the CDC as example, for people like us, you know, trying to build kind of appropriate software and distribute test kits for researchers, you name it. And then from the public, basically that kind of ongoing scenario, but then from the public DLT, the private DLT receiving notification of finalized transactions, which means that when they send that broadcast out, they get a notification within seconds, in the work that we do, or possibly minutes or hours, depending on the protocol used, that says this transaction is now finalized, which means there is a record of it on multiple decentralized nodes. It's immutable. It will be there. It shows that that transaction from here on is tamper-proof. And so if you addend it, if you have an addendum to it, or if you have other transactions of this kind, you can see it, and you can trust that flow of transactions, again, without divulging the information. So moving on. Again, now we're kind of going into some of the things that I think really are if you like, if you started from solid reality and solid implementation to a little bit more speculative, now we're really kind of into the realm of things that are really unproven, right? If not out and out kind of speculative at this stage. So, this idea of kind of cross-chain interoperability. Really, without interoperability, it's very, very difficult in any kind of large-scale system or network to build adoption, right? To build like real value. In the world of healthcare, we have, like I mentioned earlier, many siloed systems and siloed databases. So interoperability is very important. So if we're relying on blockchain as one mechanism for interoperability, it's important to have, or for interoperability of say, track and trace on transactions or supply chain as example. It's important to have some interoperability, and unfortunately, we're a little bit off from that. So, those of you guys who are familiar with the Matrix, do you take the blue pill and make believe, or do you take the red pill and take the Wonderland? So, it's a dilemma, right? It's not quite there. My thinking is there are a lot of things you can do off the chain, and if you do that off the chain and use application programming interfaces, that gives you a lot of flexibility with proven technologies that really either already work or have a very high likelihood of working. And I think to me, that's path number one. If you like, that's the red pill. Public DLTs, yes, use them, and I'm a big believer of them, but use them really for, I think, primarily for transaction finality, where a particular small transaction can be shown to have happened. So what we call finality, not necessarily for all kinds of exotic smart contract interactions that may well then become interoperable or have interoperability issues across other chains. That's one of the big issues that's currently being worked. There's an up and coming concept around network of networks. Again, it's not too dissimilar to just the blockchain idea itself with the different nodes that are decentralized, but now it's at the network level. It's a little bit easier. You can have overlay networks that communicate across the different networks, and there's some good developments happening there. I mentioned the hybrid blockchain idea, and again, it's nascent, but certainly I think it's an idea. It's the one that allows you to go from a private to a public, and again, use the public blockchain to manifest transparency, to show transparency. Exchanges, really honestly, I think now we're kind of into the world of things that don't really work. I mean, an exchange is good for if you're doing cryptocurrency exchange, but an exchange by definition is centralized. If you're using Coinbase, that's a centralized company, and really you're now breaking one of those key pillars of blockchain, which is this idea of decentralization, and then possibly giving control and the keys, most importantly, giving the keys, the private keys to one entity. And then some other up and coming technologies, oracles and parachains, relay chains, inter-blockchain chains, etc., communications rather. All these things are in there. Oracles are the idea of essentially using smart contracts to attach some transactions and activities on APIs outside of a blockchain to a blockchain implementation and things like this. But again, in my opinion, we could certainly spend a lot of time talking about these. Those are all nascent and not really proven. I mentioned a little bit earlier this idea of identity is a really, really important concept, and it's perhaps the single biggest limitation right now for large scale blockchain adoption, and certainly large scale in the true context of decentralized, fully decentralized implementation. So, and really it's because we are still largely around in this evolution of identity management around user-centric identity. All right, and if you, for instance, if you're using identity as a service, use I don't know, Okta or Auth0 or whatever, you're in that space. And in fact, frankly, that's what we do too, because that works at scale. Self-sovereign identity, which is really the direction that we need to go for, kind of truly decentralized identity management, is nascent. In some countries, in some contexts, it's a lot more mature. But here in the US, it's not. And one of the big limiting factors right now is interoperability across different standards and different implementations of distributed identity standards, or DIDs, or again, self-sovereign identity. Again, we could speak about this topic for a long time, but at least in my opinion, this is a big barrier to really kind of large scale adoption of a blockchain as a whole, though by no means a limitation to use blockchain in certain areas. Moving on, just kind of a slide, if you like, a pragmatist roadmap to how do you get there. I've already really spoken about all of this, and I'm sure for most organizations, people are probably already somewhere down this roadmap, right? Again, and not that you should do it exactly like this, but in my opinion, there's a flow and logic to this. And if you want to build interesting, useful, scalable, real blockchain technologies, starting with the last or like the penultimate items is not really where you are at. You want to start. You want to really think through what it takes to build an application this way, and how do you really get value from blockchain. So be careful. Basically, there's a lot of pitfalls and manholes to watch out for. I mentioned at the very beginning of this, or near the beginning of the conversation, this concept of data and data before blockchain. So look, garbage in, now you have tamper-proof garbage forever, right? So, or at least you have references, tamper-proof references to garbage forever. So that's a very important concept, because just because you have blockchain, it doesn't mean that the data itself is good. It doesn't mean that you can just bypass the typical practices that you would need to have to vet the data to make sure data itself is accurate, has been parsed, deduped, all those things that really are large scale data management skills that you would do traditionally. So without doing that, you're really not getting the benefit of having a tamper-proof record or provenance of the data. This idea of mapping real world to digital, so blockchain is a native digital framework or infrastructure. Most of the things we deal with is real world and does not belong in that space. So for instance, if you're dealing with, I give an example like this bottle of water, which you cannot see, or your pen as example, that's a physical thing that doesn't exist on a blockchain or may not exist, digitally. So you have to describe that, you have to map it, and that's not a trivial process. And again, not to kind of go down this path too heavily, but it's a really important concept to know that blockchain will not do the things that it was never designed to do, right? So you have to figure those things out, and you have to understand how to map things from one context to the blockchain context. I mentioned identifying people, which is a big concept, but also identifying things, including software such as APIs, right? That's a big part of what you have to do as well. Governance is a very, very big concept. It's really where I think in my opinion, a lot of private blockchain consortia may well break down as you scale them, as you try and make them much bigger, because this idea of a leader node making decisions and having veto rights, that may work with 5 known entities. But what happens when you're at 5,000? Governance is not easy. There's a number of different implementations and concepts on this, but it's an area to watch because it's evolving. To me, there are some good ones, there's some bad ones, and there's many in the middle that I think still need to mature. I talked a lot about getting to consensus, so we're going to leave that. Smart contracts, again, really many limitations to it. And then finally, dealing with legacy data, which is really old data, because the data doesn't belong or is not on the blockchain to begin with, nor are the references. So you have to understand where the data is, how do you identify what needs to go on the blockchain, and so on and so forth. All the things that we talked about in the concept of data before blockchain. All right, so moving on real quick. Here's some real examples. Hopefully this is the most interesting part for you. Before we get into that, I like this little quote from Warren Buffett. This is in early 2018 when they got together with JP Morgan and Amazon to form Haven, right? That healthcare is a hungry tapeworm of the American economy. And, unfortunately, that's really an understatement. It's healthcare is an incredibly inefficient, ineffective part of our economy. Is almost 20% of our GDP, but the amount of wastage, the amount of just lack of productivity is just mind-boggling. So I'm going to let it go, but we're focused largely on healthcare, and the barriers, if you like to, or the bar to improve things is really very, very low, unfortunately, and we're hoping to do so, but it definitely takes a village to do it. So moving on, let me see. Oh, I think I double click here. Sorry about that. Here we go. So we have a number of use cases that we have been working on, and a number of these are actually real. We have production implementation of these. So I'm going to just briefly go through some of them, just give you a little bit of explanation. But the big concept that we use is this idea of data stamping, where we basically in real time using Hedera Hashgraph protocol, we data stamp transactions, and then there's an encrypted reference or so-called hash reference of that transaction that's stored on the mainnet that is available and can be explored or interrogated by anyone publicly if they wanted to. But it's really this idea that by doing this, we're able to show data provenance. We're able to show whether or not that data has been tampered or manipulated. So here's some example. Before I get into examples, here's just a very techie chart or diagram of what the architecture looks like. But really the net of it is that it's designed to be extremely scalable. It's a serverless architecture, and very much a real-time architecture. And a number of our applications and our clients really use this technology as an API. So not necessarily the full implementation of our UI, but really at the API level. So here's, as my screen refreshes, here's an example that I think it's obviously near and dear to my heart, and I'm sure those of you guys at ASU have already come across it. It's the ASU Health Check App. The ASU Health Check App uses the underlying APIs that Safe Health Systems, and Mayo, myself, and my team have been building over the last many months. And these questions that may be hard to see here, these questions that pop up in the questionnaire that are surfaced through the apps, they really come from our APIs. But what's really interesting though is that behind the scenes, every time you go through a questionnaire and you put your questionnaire results in, such as you have a fever, your temperature is 100.4, etc. And then at the end you get what we call the endpoint, a medical endpoint that says you're symptomatic, you need to stay home. All of that is encrypted, and the results, including the symptoms that led to that, are encrypted and stored as a hash object on Hedera. So, and this is basically the real-time data sampling we're doing. The good news is all that is really abstracted from the user. The user has no idea that's happening, and they're not supposed to know. That we don't want the user to be worried about blockchain and keys and dealing with cryptocurrencies and none of that. All that is completely abstracted, but they can be assured that the data there's now a tamper-proof record of that transaction. And if later on there's questions about is that trustworthy? Did somebody manipulate it? We can go back and we can very explicitly show the timestamp. We can show that it was fairly timestamped at the moment it happened. We can show our internal cross-reference with the same encrypted, hash entry and so on. So, and again, not to get into all the details, but it's a very interesting to me is a very interesting and kind of seamless way of using blockchain in real time, practically, and to really do something that's very important, which is to essentially what I think of as impute computational trust into this entire flow. One more slide here. We also use the same kind of concept, same data sampling approach for generating a unique ID. We call it National Health ID through Hedera. But again, it's this idea of a unique ID that's associated to a user, but there's an encrypted reference of it on the blockchain, right? And then the thing that's really interesting, and this is really across all of our implementations, is that we, by using the Hedera Hashgraph protocol, not only do we get to transaction finality within about 3 or 4 seconds and at a very high scale, but we do it incredibly economically. So we're able to essentially run, well, I mean, let's give you some real numbers. We have run, I think, over 4 million transactions in production already, with our data sampling services. And the cumulative cost of that, is a fraction of what we would have done, for instance, had we used, Bitcoin or Ethereum network. So it's a very, very economically viable approach for building this kind of system where you have literally millions of transactions, and it's really growing. I think we hit production in June with basically just 1 transaction, and now it's already over 4 million and exponentially growing. So I think most of you guys are familiar with us, have seen our coronavirus tracker. It's on our website. It's, I believe, the only one of its kind that's blockchain enabled, where every one of the transactions, as I've described, has been data stamped with, again, using Hedera. But perhaps a more interesting one is this application that we have done working with state of Alabama. It's really all to do with mortality and substance abuse reporting. And I have a little kind of animated video here to show you what happens here. So as you can see, there's a fair amount of real data that we have visualized. All of this data is coming from the client's internal data sources. We have transformed it into machine readable data. We have visualized it. We have built it into a case management type of system as well. And for a number of these data elements, and here I've obscured the patient information for obvious reasons, but we're able to basically, and you can see it just on the bottom, we're able to show the provenance and the movement of data. But then very importantly, in this last slide, you'll see this idea of a trust. This, if I can show my mouse here, it's stuck. Well, here we go. This idea of a trust button. Basically, what this shows is that while the client knows, and we know that these transactions have been data stamped on the blockchain, but if they click on that trust button, they will be able to, in real time, verify that for themselves. And I have another example that actually shows that. So moving on, let's see, here's the next example. Again, a similar kind of concept. This is for tracking agriculture supply chain in Uganda. We're working with a client in Africa on this. Similar kind of data visualization. Again, the data itself is coming from multiple data sources and is data stamped. And this is very, very important because this data is used essentially for the government to subsidize more or less economically to these farms, but also to prove to the buyers, particularly European market buyers, that that fair practices are being deployed, that the right kind of agricultural chemicals are being used, that that it's not fake information and so on. So it's very, very important that the data can be proven to have the provenance that we claim to have. And in this case, the actual data is coming literally collected from the farm by the farmers and going through various kind of channels in that supply chain all the way to the buyer. Moving on, another example. This is one that you can look at yourself. It's called flighthash.com. So I encourage you to look at it. It's one that we're doing for another client of ours, not in the healthcare space, obviously. If I just click on this, you'll see what this looks like. But I encourage you to kind of look at this yourself. It's on the website. And you can kind of see here, we're just demonstrating this with Atlanta Airport. You're able to go in there, you're able to look at what's going on, flights near Atlanta, and you're able to click on a specific flight, and you're able to see that flight, you're able to see and we refresh this, I think, every 5 seconds. You're able to see the real-time, essentially, movement of that's recorded, basically, on the blockchain, so we can prove. So if somebody said, and this, by the way, happened actually at the beginning of this year, when you may remember there was a Ukrainian flight that was shut down in Iran, and there was a lot of back and forth about, well, no, it really wasn't. It was going somewhere else, etc. But had they had the system, we could have categorically proven where the flight was. And then what you see here is this idea of what we call a trust score or confidence score. But we have taken that down below here, this, let me see if I can move my mouse. It's stuck. Here we go. Down below, we've taken this encrypted message, and we're proving using 3 different explorers, network explorers on the Hedera network that have nothing to do with us, that the same transaction is recorded, or they show the same transaction recorded on the network explorer using their own network explorer, and then we generate this confidence score coming out of it. Let's see, I have 1 or 2 more examples. I apologize, I'm running a little bit long, but hopefully it's not too boring for you guys. Let's see, why is this stuck? For some reason my PowerPoint seems to be stuck. Okay, oh, we skipped one, apologize. Let's go back up 1 more. There's 1 more interesting one. And this is the last one I'm going to show you. Again, it's available for you on newshash.io. You can look at this. But this is really old. We're working right now with an outfit in Asia. And it's really all to do with proving fake news, which is a very, very important topic, obviously, right now. Let me just play this so you can see what's going on. Okay, it doesn't want to play. Let's try 1 more time, and if it doesn't, then we'll go. Yeah, all right, apologize. For some reason, the last video does not want to work, but really, actually, if I have, Timothy, do I have time to show it live or not?
Yeah, you've got as much time as you need, Jim.
Awesome, awesome, great. Well, let me just apologize. I don't know why my computer has decided this is the right time to be very, very slow, but that's exactly what it's doing. Yeah, okay. So I'll show this to you live. So, can you guys see my screen, by the way? Hopefully, yes.
I can see your screen, Jim. I'm not sure if the audience can. Maybe give us a thumbs up just to confirm.
Yeah.
All right. Got some thumbs up coming in, Jim, so you're good.
All right, good. Yeah, sorry. I don't know why it's taking such a long time to refresh. It may be Zoom that's acting up here. Do apologize. This is flight hash that I'd spoken about. Here we go. Okay, so if it lets me, I know it's really being finicky here right now. Okay. Yeah, this is my machine is just being silly. All right, so if this cooperates, I will show this to you. So it's what we're doing here, just as a demonstration. Like I mentioned, we're working with a news outfit around this, but we're taking essentially news published from the BBC, some news, not everything, and we're just demonstrating this concept of data sampling in real time. So this is so let's take this one, coronavirus in Spain passes 1 million cases. So that's the actual link to the article. If I click on that, that will take me there. At the moment where we took, you can see at 4:43, where we took this particular snapshot, or we took this recording, we created a snapshot out of it. So if it changes later on, we have a visual to go with the snapshot, and hopefully this will pop up momentarily. Yes. Yeah, this is my computer. It's just being very, very slow. You can kind of see here, this is the full article as a, if you like, as a immutable image now, right, that we've recorded. But then back here, I'm all, because I can hopefully prove that this actually is a real one. Oh man, what is going on here? Okay, so I'm going to click on Get Proof, which you can see in real time now. This has basically taken this barcode shows me the essentially a manifestation of the code that we have here. It's not showing for some reason because I think it hasn't refreshed correctly. This is the actual entry, and then normally I can just click on this and it'll take me to the transaction, but my machine is not refreshing. So I'm going to wait for this. Let me see if this one does it any faster. Yeah, I apologize. I think for some reason Zoom is killing the CPU on my machine. So, and I'm not going to in real time go into my monitor and kill off some processes. But anyways, you guys can do this by yourself, and you can pretty easily see what I'm talking about, where you can now click on the transaction and can see what really is happening on the Explorer level as well. But that's really it. That's kind of some examples. I think the big thing I want to kind of let you guys know is that there's an opportunity to do some real things that are useful, that are fast, that can be done in a very quick way, that are economically feasible. And I encourage you guys to explore and to look into it, because it doesn't have to be this kind of all or nothing full utopia of a fully decentralized world, where everything is, the entire process decentralized, and you have self-sovereign identity and very usable key management, all those things that we talked about. I think those will come, but in the meantime, there's a lot of useful things you can do now that will at least give you confidence in terms of authenticity of transactions, right? And then you can do more later on as you get to it. But certainly, I think that's that's a concept that we believe in. That there's plenty of useful things we could do now, just to kind of show, or at least for certain industries such as healthcare, where you really need to show compliance, that you can show that compliance and can do it simply. You can do it in real time. You can make it interesting and build into applications. It doesn't have to be some kind of a difficult, or some kind of a gigantic investment or a difficult user experience. With that being said, I think that's the end of my time. I'm going to get back to the question slide if I can. Looks like it's stuck, but I get there. So, Timothy, I'm happy to take any questions if there are any questions.
Fantastic. Looks like there's one in the chat.
Gotcha. Would you mind reading that to me? Because my machine
No, not at all. Not at all. It says, will you talk about the patent elements of Hashgraph versus the open source dimension of trust associated with other blockchain and DLT constructs? And there's a second part of the question, which says, is Acor proprietary or open source?
Yeah, lots of good questions. So I didn't really kind of get into the specific protocols and consensus algorithm of the different technologies, but my Windows stuck here, so I'm unable to go back to my PowerPoint to show you what I'm talking about. So I apologize about that. But basically, the question is, or what the question really alludes to, Hedera Hashgraph having a patented consensus algorithm. It's called the Hashgraph algorithm, right? It's based on a variation of proof of stake, what's called a kind of gossip by gossip proxy voting, to be very technical about it. And that particular patent, the underlying math around it is not it has been, the underlying math around it is based on this concept of what's called asynchronous Byzantine fault tolerance. That's been around for about 30 years, right? The math around it. However, the actual implementation is patented. It was developed by Lehman Bird, who's a co-founder of Hedera Hashgraph, and it is not open source. However, it is open review, and in fact, you can go and look at it right now. It's available. They've made it open review. So the reason why they don't have it as open source is because they don't. The big concern is forking of the code, and then essentially, and you've seen this, I think, with Ethereum in particular, where you have many different forks. You saw it with Bitcoin as well, with the Bitcoin Core and the kind of the contentions that they went through. Actually, I've gone through a number of times. So the underlying reason, really, at least as I understand it, was to prevent forking. So there's only one source of the consensus algorithm. So that is a little bit different for sure to most other protocols, which are pure open source. And you can go to GitHub and download the source code and look at it at your leisure. Is it a concern to me? It was a concern to begin with, I must be honest. That like 3 years ago, or 3 or 4 years ago, when Swirls came out, with Hashgraph, we really questioned whether or not we wanted to experiment with this because of that very reason, that it wasn't open source. And the bulk of what we do, what I have done is open source. However, as time has gone on, really two things have materialized. One is this idea that Hedera has shown, at least to me and many people who have experimented with the product and worked with the company, that they do have a lot of measures in place to make sure that the fact that it's patented is not abused, and it doesn't become so proprietary and closed that then you essentially are building kind of solutions based on something you have no long-term kind of, or you don't have confidence in long-term, that they could be essentially at the mercy of one entity. And I think they've proven this also with the way they've gone about building the governance model for the Hedera Hashgraph public DLT, right? I think right now there's 16 very large public companies that are part of the or not all there's one academic institute as well, but this governance model where essentially these 16 organizations really own Hedera, and then in time will grow to 39 is one of the reasons why I believe that this concept is going to stick, and there's many other reasons where I see them really having a long-term point of view, and the idea of the algorithm itself being patented is not as much of a concern to me. The other thing is that, like I mentioned, they have made it open review, which means we do have the chance now to go and look at the code. We do have the chance to interrogate it. We do have the chance to talk to them, at a technical level. So that certainly allays some other fears as well. Going back to your second question, we are typically an open API company, Acor is. We build things, really, I think of it with interoperability by design. We try and build with open APIs. What is called the open API spec or Swaggerized API spec. That's really how we've built our own software. That's how we have built the majority of the safe software as well. Very much with the idea that our software should be able to be consumed and consumable by third parties in a very much a standard way. Open source, again, this kind of gets into a number of things that to me are beyond the scope of like Acor at this stage, because I think ultimately for us to build solid open source software, we need to build a foundation as one underpinning element of the business to be able to do that. And right now, even though we very much believe in open source, we just don't have that the financial wherewithal to do that. So the answer to that is no. Hopefully that answered the question.
Actually, Jim, I think that's a pretty solid response there. The person who asked the question, to thank you. I really appreciate the fact that they asked the question as well, because maybe you can shed some light for us on the work that Lehman and Mance have done with Hashgraph around. Didn't it start with Swirled and kind of start as like a permissioned Hashgraph for the National Credit Unions Association or something like that?
Yes.
Is that? Do you know anything about that?
Yeah, precisely. Very good memory. That's exactly it. That's how they started. I think that a couple of 2 or 3 early adopters. But it was very much, I think for the first year, it was very much a private blockchain implementation. And to be honest with you, even though we really liked, we got the SDK, we played with it. This is when I was at the CDC. We liked it. We really liked the technology. We loved the consensus algorithm and just many of the things about the team itself and just the potential, right? Because it's not a trivial thing to get this kind of scale with an economically viable model, right? It's a really quite a rare combination. But all to say, we really didn't do much more with it because we did not want to go down a private blockchain path. And we actually built out our own Ethereum network, when I was at the CDC and continued thereafter. But then once Hedera became reality and once we heard about that, that's really when everything changed. That's when, it really kind of led us down the path of what we wanted to do and kind of philosophically in line with what we wanted to accomplish using a public ledger and this idea of transparency, which I think is really, really important for anything with the word public in it, like public health. To me, transparency is incredibly important, at least at this ledger level. So that's really where everything changed. And we kind of fully committed to Hedera and we have not really looked back.
Can you share maybe, one of the things that I noticed recently, I was at a conference maybe a year or so ago in Atlanta, and the Hedera team actually was very much, they said, look, we're open source. I really appreciated you sharing kind of some of the insights on that, on the back end. Curious, are you following along any of the other really major sort of projects that are going on out there? I just recently have been hearing about like Holochain and all of these other, sort of projects out there. Which ones are you following along, Jim? And kind of, what are the ones that kind of, that you're looking at and you're like, these guys are doing something really interesting?
Yeah, it's a really good question, Timothy. So, obviously most of us in this space tend to be curious and it's a very evolving space, right? Like I mentioned, just the cross-chain options, are in the dozens. And there's some really interesting ones like Quant and things like this. But to be really honest with you, my whole team, we are so incredibly busy right now building software, real software that's being used, in fact, by people like yourselves in production and the myriad things that kind of go about doing that really we're honestly firmly focused on Hedera in terms of our blockchain protocol. Where we are kind of looking at alternative options, or really not alternative options, but just some other options, is really around identity management, right? So that's a big one. I mentioned it's one that I think is really critical to large-scale adoption, and it's really enormously important in general for all kinds of reasons, including socioeconomic reasons and to drive certain disparities forward, et cetera. It's not just a technology conversation. But we've been looking quite a bit at what Sovereign is doing, with ID 2020, the Microsoft effort there, and of course just straight up like Uport and just doing it just with straight open protocols that Ethereum has. So we've been looking at that, but all to say we're I don't know if we're at any kind of like real conclusion. In terms of adoption anyway. We have obviously some opinions, but if I had my druthers and if interoperability was there, some kind of an SSI kind of solution would be the way to go. But I don't think we're there right now.
Sure. Jim, one thing that would be, I think might be helpful as well, you mentioned Hashgraph. Maybe you could just kind of say a few words about the difference between like Bitcoin, not Bitcoin rather, but like blockchain versus Hashgraph, or, kind of, talk to the audience a little bit about like that, like what's the difference between those two things?
Sure. Yeah. So course, blockchain is used really kind of, as a catch-all to describe all of the technologies in this space. I mean, really, if you're technically accurate, blockchain really is what you would consider as a traditional kind of proof of work implementation, where you really have, or not proof of work, but really kind of blocks of information that are chained together. So there's what's called the Genesis block, which is like the very first one, and every like block of information, which is really like a collection of information, thereafter is sequentially chained or linked to it, hence blockchain, right? And then what happens is that you basically have, like I mentioned, you have these network nodes, and every one of the nodes, essentially before you get to transaction finality, and in the case of Bitcoin, it takes like 10 minutes to do so, minimum 10 minutes. Every one of those nodes really need to, or one node races to solve a mathematical challenge that proves that a transaction happened, as in, Jim sent $10 via Venmo to Timothy, right, as an example. And then all of the nodes basically copy that transaction onto their ledger, right? That's the traditional blockchain. Hashgraph really is not traditional in that context. It uses this what's called a directed acyclic graph. It's really like a tree, but in order for you to get to consensus, you don't need all of the nodes to have, or to get to transaction finality. You don't need to have all of the nodes agree that transaction happened. You only need to have 2 of them do so to begin with. And the algorithm, and this is one of the reasons why it's incredibly fast and financially viable, is that the algorithm itself is on the node. You don't have to traverse the network and generate network traffic for doing so. A very, very small amount of metadata, really what's called gossip, is shared across the nodes or by the nodes. And once those 2 nodes essentially finalize a transaction, then using this gossip by gossip mechanism protocol, the rest of the nodes are updated. And also, you don't really have this concept of a genesis block, because the tree, this hash graph tree, if you like, can and does get trimmed. And there, in fact, there's an opportunity for third parties to basically provide archives or explorers of old transactions and things like this. So fundamentally, a different way of getting to consensus is really what it's about. But also, certainly when you think about traditional blockchain, it's much faster and at much greater scale, like number of transactions at the same time. I think right now is around 10,000 per second, and a 3-second kind of a delay to transaction finality. So those are like incredibly impressive metrics to build from, because that's really a real-time system.
So Jim, it sounds like, from what you're saying, there is an efficiency difference, there's a speed difference, and a lot of this kind of roots back to the way that they do consensus. It's really fascinating, because from the Hashgraph perspective, it sounds like you're actually almost even increasing your speed, like from blockchain to get to finality, from blockchain to Hashgraph, you're almost increasing your speed by almost like 1,000%, if not more. I mean, it seems really substantial.
Yeah, and that's, it's a very, very important concept, Timothy. It's this idea of transaction finality, because transaction finality is a thing that we use to say, and again, you can see this yourself on Flight Hash or Muse Hash. That's the thing that allows us to basically spin up that barcode, or to give you the encrypted or the link that takes you to the Explorer and shows you the encrypted message that's been recorded. If you don't do that, if you can't do it in real time, many use cases are really just not going to work, right? And certainly in what we try to do with our applications and in healthcare is to make it much more consumer-centric. Abstract out the code mumbo jumbo, but if somebody wants to see it, make it real, make it seem like as part of the same transaction cycle as what they're already doing functionally. And I think, with most protocols, you're just unable to do it, or it's extremely costly.
Absolutely. This is really, really great. I learned a lot today. And, Jim, I want to thank you again for joining us here. There's just so many things that we learned, just in terms of blockchain and just in terms of what Acor is doing. It sounds like there's some really innovative things happening on the healthcare horizon. Really quickly, before we wrap up, last question for you, and please, if anyone else has any other questions, please feel free to put them in the chat, and we'll share them here. But Jim, it sounds like healthcare, are you guys like on your own kind of innovating in this way, or are there a lot of players innovating like this in healthcare? It's such a complex challenge, healthcare. So just curious.
It is a complex challenge. And it's, I hate to say it, Timothy, I'm going to not get on my soapbox, I promise, because I do occasionally on this, but it does irritate me because I feel like the healthcare industry is artificially difficult to break into for startups. You have all these rules and regulations, and in some ways it's very kind of it's a closed, it's kind of a closed eco, right? So what that does, it tends to dissuade many innovators or startup companies to get into. And I think that's a shame, right? That to me is a real irritation, because the industry really needs us, right? More so than most other industries. Like, I give an example. In the financial services industry, in order for me to bring return on investment, I have to improve the fitness of the model by significant margin. In the healthcare industry, if I improve it by a tiny margin, you get big yields, just because the numbers are so big, just because it's so broken, just because, what we're talking about is so important, yet there's not been that much innovation for a long time. So all to say, I don't think there are enough startups or enough real innovators, especially people who are taking like blockchain and some of the things that we're talking about and trying to adapt it or apply it to real healthcare kind of concepts. Not, again, I know a number of people are doing really cool things with machine learning, and again, I'm all for that. I think that's great. But honestly, there's some more like garden variety things you can do. And I consider a lot of what we do garden variety, right? Because it's just about like, can you trust the data, right? We're not talking about like, putting together, a kind of a distributed cluster of Spark servers and doing, auto ML across 100 different databases. That's not what we're talking about. We're talking about, can I prove that somebody did not manipulate the data? Can I prove where the data comes from? Can I prove that I had patient consent before I share the data? Those like simple things. So not enough. Where I do see innovators getting into it and using blockchain is really around patient data access. That's where we've seen it. There's a number of startups in that space, and I think it's great. It's great to do that. Honestly, again, I'm kind of pragmatic. To me, that's patient data access is one that, or kind of patient-oriented healthcare is where you're going to get the biggest return on investment over a course of time, but not. I don't think it's really going to happen over the next year or two. I think this is like a decade or two out, right? That's the nature of I think what the space looks like, which is unfortunate, but I think that's what the data points to. However, there's a lot more mundane kind of things. For instance, showing, I give you a very specific example. In the pharma space, there's this thing called the Drug Supply Chain Security Act. It becomes law in 2023. It means that every single artifact that goes in front of every single artifact associated with a compound that goes in front of the FDA. And to give you a perspective, most compounds have over 1 million digital artifacts. They need to have a digital audit trail. It needs to show that the FDA at any point in time could ask for every file, every associated note, every collaboration, everything for that in a digital way, in a way that is tamper-proof. That is a huge ask, yet that is an ask that is exactly fit for blockchain. It's designed. I mean, the data sampling concept that I just described to you guys, you could easily apply it for those artifacts. And it can be done economically, it could be done at scale, it could be done without divulging privacy information or a kind of confidential business secrets or anything like that. Yet, I don't think there are enough people thinking about that in that kind of context.
Wow. No, thank you, Jem. That's awesome. This is great. Thanks again. It's time for us to wrap up. We're at 5:30. Want to say thank you again, Jem, for joining us today. And thank you, everyone that came to join. Look forward to having you join us for our next Innov8.
Is there some way that we could ask questions, outside the context of this? Because I got a bunch of them.
Derwin, great question. Jim's contact information is right there. Phil, Jim, I don't want to volunteer you. I'm imagining that's why you put the contact info up there. But to Derwin's question, what would be the best way to maybe reach out and ask them?
Yeah, absolutely. I'm happy to answer questions if I can, for sure. Certainly, my email is right there. Feel free to email me. I'm on LinkedIn and Twitter. So those are the easiest ways to get hold of me.
Well, can I ask a quick one then? Because this is one of my favorite subjects. I'm fascinated by this whole thing, but there's always, I think there's a failure to recognize the white elephant in the room, which is, of course, all of this is based on PKI. And as we all know, if it weren't for the fact the government was kind of sidetracked by this major crisis going on, they're still consistently trying to prevent us from getting the foundational technologies that we want. In other words, they're looking for either key escrow, backdoors in open source software, and if they can't get them legally, then we've got the NSA with Bull Run that's doing it on the back end without anybody knowing what's going on. So. And then there's all of the other things that go along with that, particularly the identity aspects of it. And some of the things that you had mentioned, for instance, about what goes on the blockchain, and you were kind of implying that there would be audit information or metadata about the transaction itself, including who did what at what time, all of this kind of thing. That's probably an issue in the design of the blockchain itself. But the other thing is okay, so there still are the issues of identity assurance as to, who's proving, to what degree do you prove the identity of whoever is actually initiating a transaction? Yes. What can you say about that?
Yeah, I mean, you raise obviously a very deep topic and a really important one, and one that I'm certainly not going to pretend I have any or many answers for. So let me take the simplest one first, right? What we do in terms of identity kind of management and proving vetting identity is that we do that off the chain. That's not on the chain at all, right? And we have a whole essentially conventional process, including like videos, like selfies with videos and driver's licenses, and actually, since we're white label our application, when we have, for instance, ASU as an example, relying on the client's own vetted list of users, right? And then doing an SSO to connect with them. So we really do it the old-fashioned way, right? We are not doing SSI. I do want to say though, just to kind of make sure it's not confusing. On the audit trail that we established using our data sampling, we do not store like any personal information at all. Like there's no, like we don't say who did something. We do timestamp, obviously, but there's absolutely nothing that can be kind of re-engineered. And of course, everything is hash encrypted too, right? There's nothing that's unencrypted that goes on the public DLT, right? But nonetheless, we're very, very kind of cagey about that. And as I mentioned earlier in my conversation, I'm a big believer, we're a big believer on a lot of things happening off the chain. So we use APIs and do it off the chain, right? But to your larger kind of question of, essentially the government or third parties having access to, the private keys and managing private keys. Again, I kind of talked about it a little bit, the key management thing. I didn't get into a lot of details, but it is a very big issue. And then the other big issue that I'm sure all of you guys are familiar with, or at least have heard of, is what happens when you have quantum computing in the mix, right? Because that's, in theory, quantum computing can basically eradicate every one of the measures we've taken in terms of encryption technology right now. My belief, and maybe it's just my wish, is that there is concurrent activities happening. So once we get there, if we get there, there will be commensurate cryptography to combat that, right? That's my belief or my thinking. But yeah, I mean, it's really thorny. I mean, it's a very, very difficult topic. And it's one of the reasons why I feel like if you get into decentralized key management, you really have to very, very carefully pick what you're doing, and also, frankly, very, very intentionally build what's off the chain.
Excellent. We're starting to run down to the end here. Derwin, I encourage you and really anyone else with any additional questions. Jim's a wealth of knowledge. Feel free to reach out to Jim, follow him on social media, connect with him. And we look forward to having you here next month. And Jim, we look forward to having you back.
Thanks so much. I appreciate it. It's great to talk to you all. It's a shame we cannot do it in any kind of a interactive way, but this is good enough, I guess.
Yeah, and you made the content interesting. Hey, but thank you again, and everyone, thank you, and hope you have a great evening.